The broadcast is now starting. All attendees are in listen-only mode.
Okay, good morning everyone. This is Doug Nesbitt. I'm with Extron, and welcome to our latest New Paradigms in Supply Chain Design webinar. Today's webinar is Managing Demand-Side Volatility in Global Supply Chains. And today our presenter is Sandeep Duggal, our CEO of Extron. And Sandeep has served as the CEO here of Extron since 2002. He's responsible for setting and executing the company's strategy, business development, and overall company performance. Prior to joining Extron, Mr. Duggal worked at Sun Micro, Intel, and the Monitor Company. He holds an undergrad degree in mechanical engineering from the University of Michigan in Ann Arbor, graduate degree in industrial engineering management from Stanford University, and an MBA with distinction from the Harvard Business School, Harvard University. If you have questions after the webinar, please send them via the questions panel to the GoToMeeting webinar control panel, and we'll address those at the end of the presentation. If you'd like to schedule an individual discussion with Sandeep, please send an email directly to him, and his contact information will be given at the end. Thank you, Sandeep, for presenting, and I'll turn the webinar over to you now.
Thanks, Doug. Welcome, everyone. Appreciate people taking time out of their days to attend our webinar. We think it's a especially important area, especially given where we are now in terms of job creation and also with respect to the huge changes taking place in the global supply chain. This webinar builds on the previous ones we've done that pertain to game-changing moves in supply chain design. This webinar is a little different, though. We get more into detailed questions of planning and execution and less into strategic questions. But you'll see that in general, this follows the theme of our last mile design. So without any further ado, what I'll do is move forward. Our agenda is very straightforward. We're going to cover product configuration, forecasting, give a little background on globalization and how this has affected it, talk about new dynamics, our new model, then go over a case study before we get into questions. So first thing to remember is product configurations changed. Earlier, this goes back 100 years, but it's a classic example. The Model T had one variation. It was, you could get it black, and well, that's about all that you could do. There were no options. That's how companies back then managed variability, and that gives you a sense of how much power the consumer had. Even more recently, and this is going to take us into the 90s and even the 2000s, forecasts are done very simply. They're done through MRP. A primary forecast is loaded. The primary forecast consists of allocated forecasts on different options that are available of a product. So if you're forecasting 100 different network devices, you have to guess as to how many of them are going to have one antennas or two antennas or three antennas, and how much memory they have, what kind of software they've got. And so you basically have to allocate your forecast among the finished SKUs. Oftentimes, the result is over-forecasting or under-forecasting, and we'll get into that a little bit later. Obsolescence, lost sales, inventory costs, and then scramble to rework product when you got one set of finished goods and you find out you actually needed a different set. The globalization of supply chains has made this even worse. As components have been offshored and the supply chain has been moved to third parties as opposed to being the manufacturer themselves, hands-off management has resulted in even further distance of the supply chain from the corporations that do the marketing, that actually own the product. As they focus on sales and marketing and not supply chain oversight, as they have globalized supply chains that are far away, and as they have third parties doing it, the whole management of inventory and configurations has actually been in fact delegated to people that operate on very different economic ground rules. So the pendulum, as we said in previous webinars, has swung very, very far. But we believe it's beginning to swing back for a variety of reasons. The biggest one is changing behavior of the consumers. Certainly in the 90s and definitely in the 2000s, consumers began to want on-demand product. They wanted it configurable. They wanted to do ordering over the web. They wanted to be able to order whatever they wanted, when they wanted it, colors. And this is not just consumers. This is business consumers also. If I'm a company and I want an 8 megabyte system and I don't want 16 megabytes, well, I want to be able to order that. If I'm a retailer, I want to have my own SKU. I want my promotional data on it. I want my name on it. I want my own UPC on it. This has made configuration a headache for OEMs. And the proliferation of SKUs, of outlets, of choices has become very difficult. There's also the additional dynamic of architecture-specific SKUs. This is extremely key just in the wireless telecom area, but I mean, that's only one example. Whether you're a consumer or whether you're a business, the idea of on-demand, highly configurable products have permeated and have become more and more prevalent as consumer power has grown and as competition has increased. Bearing in mind the context, this has been, a problem. So the impact of misforecasting, which is now even more prevalent because there are more SKUs, has been especially tough. We're doing rush deliveries, flying the product in, which is obviously profitable. Let's remember that transportation of a product adds no value to the product. It is simply an enabler of your globalized supply chain. Let's also remember that when you delay delivery of your product, you lose sales to competitors or customers simply find another solution. There's no time like the present to make your sale. So the impact of misforecasting when consumers have choice and when there's the opportunity to perform rush orders, especially when freight is looked at as cost of doing business, is especially nefarious. So let's get down really into the details over here and talk about inventory required versus lead time, right? So classic, when you've got a longer reorder lead time, your inventory goes up, and because we have globalized supply chain, when your reorder time goes up, as it does because of transportation and language and other barriers, inventory is going to go up. Just to flip, so classic relationship, you'll see this in every single production operations management book from just about every single university. Now, how this impacts inventory over time is as follows. When you have inventory at a peak level and it comes down in some predictable path, you have to order that inventory at this reorder point because your inventory keeps going down while the inventory is produced, and when it finally is available, inventory will jump up to the peak level, with the reorder time being the time between when you place the order and when you receive the inventory. And ideally, you have as small a safety stock as possible, which is shown by the lower dashed line. And if demand is all predictable, this is how you're going to receive this is how your inventory varies. The slope of the line is the rate of consumption, as you would otherwise expect. So this is a no volatility scenario. Unfortunately, this is not the real world. The real world is demand comes in faster than you expected, and you're out of stock. And you're out of stock for all this period in the yellow. The other scenario is demand doesn't come in the way you want it, and you have excess inventory. Now, bear in mind that in this case, we're talking about one SKU. If you have 100 SKUs, you can multiply this number by 100x, or you can superimpose 100 different inventory items, and you have a fairly complex situation where you're now needing to pay for inventory, for storage, for rework. A lot of problems with this classic model. Now, to be fair, a lot of companies have moved beyond this, but this is the classic inventory scenario. Let's superimpose that inventory now with the current supply chain model, which is you build your products overseas, you have them done by a contract manufacturer who configures them with the right labels, the UPC codes, and your product is flown in, God forbid, or brought in by ocean to a distribution center, and you try to keep some of these things here domestically, and you struggle and you kind of figure out you may use multiple vendors for these, your own returns op department, and outsource the distribution and have a different warranty pool, and you figure out the rest and hope for the best, but really your operations are handily stationed overseas. This is the classic model. We would argue that your supply chain is not at all flexible. You are kind of stuck, to go back a little bit, you're kind of stuck in this scenario when you have this kind of supply chain. And the key thing is, how do you strive for what would seem like an anomaly, which is mass customization of your supply chain? So, mass customization is the holy grail. The problem has been it's typically been very expensive. So, this is the goal that we believe that most customers, most OEMs need to strive towards. The use of flexible manufacturing to produce custom output, which results in individual customization, yet the low unit cost of mass production based in Asia typically, or wherever it may be, Mexico or wherever. The core idea here is that this is a new frontier in business, and you can increase the variability of your product without increasing cost. So this gives a company strategic advantage over their competitors and should result in the almost complete elimination of demand-side volatility impacts, specifically on the negative side, but there's actually upside on the positive side also, but almost a complete elimination of demand-side volatility impact. Here's the bad news. The companies that choose to do this need to work a little harder. They need to invest a little bit more in their operations team and make them a little stronger. So how this is achieved is through a well-known supply chain strategy called postponement. This is well-known, but it's amazing how few companies use it, choosing instead to just do things the old way, build in Asia, fly product in or bring it in by ocean, and deal with massive warehousing stock, because companies pay zero, they ascribe zero cost to transportation, and they ascribe zero cost to inventory and inventory obsolescence and to rework. Those are things they deal with later on, and I think many people in the audience know exactly what I'm talking about. So postponing the task of differentiating a product until the latest possible point in the supply network is what is known as postponement. That's one definition. And scholarly research has shown this has got proven improvement in customer satisfaction also, aside from the inventory that I tend to focus on in my mostly operational mind. So let's look at this for a second. I'll pause for a minute as you look at a simple laptop and look at the different configurations that are available. This Dell laptop has 5 main product lines. Those 5 main product lines have 5 screen size options, 6 OS options, and I won't bore you with reading the rest. Point is, if you multiply every single number by itself and calculate the number of permutations and combinations, you end up with a huge number. 5 times 5 times 6 times 3 times 10 times 6, you get the picture. The consumer expects this today. Competitors are driving this. Your competitors are driving this. And if you can't respond, you will lose out to them. This is just a simple product. This similar breadth of configuration applies to storage, network appliances, MP3 players, speakers, you can just name it. So on this Dell laptop, just so you know it, 324,000 configurations. You cannot possibly stock this. Dell doesn't stock it. Dell is actually a leader in postponement, and indeed one of our customers that does postponement within our four walls over here. They understand it. I would argue that every company in the world needs to understand this, especially if they do business in the United States. So now, this is what forecasting looks like. It's done not by finished products and aggregate forecasts, but through component level planning. Many companies don't do this, and indeed systems don't support this. You forecast at the component level. The result is, I won't get into the mechanics of this, maybe we can address that later if we have time. But the result is you get faster response time, less rework, and lower inventory costs. Because you're forecasting at a component level, you can build your finished goods product. You don't, because you're not forecasting at the finished product level, you're not changing finished product 1 to finished product 2, or finished product 2 to finished product 3. You don't load forecast at the yellow block level. You load forecast here at the component level. And you understand the relationship between the blue and the yellow. Systems don't support this, but a sensible subcontractor, a sensible consultant, a sensible partner can teach customers how to do this, especially since most customers have gutted their manufacturing staff. You do the forecasting and you understand what sales channels and customers you need to put in. So your components are understood by each of the channel and customer, but you move to a build-to-order model. Now, let me be very clear. Your component can be almost finished good. In fact, it can be a finished good if you're in the consumer industry. And it may be as simple as moving a component to a finished good, maybe as simple as packaging. So your second component might just be packaging. But in the consumer business, that can be the difference between air freighting $100,000 worth of product versus $30,000 worth of product because product expands. It may be the difference between spending tons of money reworking product 2 into product 1 because component C, which was a label, can be applied to component A, which is the finished good, to generate component finished good 1 as opposed to stocking finished good 3. So there's a lot of, maybe we can animate this in a future webinar a little bit better to show how these relationships work. But I think you understand the concept of postponement and how this helps. So what we have to do is think of the supply chain in two components. A globalized piece where you build your components and a last mile piece where you localize your components. And this is what we at Extron refer to as a local supply chain or last mile manufacturing. Second, you add control at every step. You understand your AVL, you understand your subcontractors, understand your components, and understand your cost in every single one of these components. And you design your supply chain, preferably with the help of someone like us. So this results in a supply chain this is the old supply chain. This results in a supply chain that you now call globalized and localized or in-market. Results in a supply chain where you perform your configuration at this vendor, not at the yellow vendor. So there's a yellow vendor and there's a blue vendor. And where you actually take some products and move them to the blue vendor because you want to add those components, so you customize the product here at the final configuration stage. And you might find that this component is actually cheaper. Packaging may be cheaper in the United States than sourcing it in Asia and moving it to the US, especially if you have to fly in your finished goods. Or if you've got changes in packaging or customized packaging. Or if you've got a power supply that you don't want to fly in and you want to just source locally and it can be shipped in by container. Then I'll just cover very quickly is that these are some of the advantages, and you can look at these in a, on the webinar. We could discuss it later, but it generally provides you more flexibility, greater control, lower cost, and lower inventory. So this new model is adaptive, flexible. It's less volume sensitive because your CM at this point, we didn't get into that point too much, you tend to have a tiered CM structure who's happy to do business with you at lower volumes. And it's based on total landed cost. In other words, you now are becoming more sophisticated and building in the cost of freight into your analysis. There are other benefits. It's less exposed to risk. It's got less IP risk. It takes consequence of and pays economic value to geopolitical supplier risk and macroeconomic, i.e. currency risk. You can move things around much more easily. The other side to do this is that you separate out high volatility components. Your overseas components may be commodities. You can have your commodity vendor, your overseas vendor, put these together. And on the left side and upper side of this dashed line might be your commoditized supply chain. Then you've got your configuration-specific components, which you go through a completely different analysis of. Where's the best place to put these on? What is the inventory cost in these locations? What's the cost of integrating these products overseas and transporting them, or is there a different transportation cost if I associate them in the last mile integration? So there's a completely different analysis that takes place for components D, E, F, and G, which are your configuration components, memory, hard drive size, screen size, packaging, cables, software, which obviously makes sense to put on at the last mile anyway. That almost goes without saying if you have a highly configurable product based on software. So when you do this, you end up with a supply chain that looks like this. Recall our original supply chain. Add on in this now let's add just one component. Let's pretend that this product is configured with just one component. And what you do then is reduce the amount of inventory. Let's go back a little bit. In this scenario, you have high inventory because you're trying to maintain safety stock. You're trying to maintain inventory for all potential kinds of customer orders. Let's assume this is 2 SKUs. Now you add on a different inventory of a second product. It may be simple as packaging, or it may be a hard drive. You reduce the total inventory, and you add inventory of the second hard drive. Your total inventory will go down, as shown in this mix over here. How much it'll go down depends on what your product is. There are significant other advantages, but your total inventory of DEF adds up to the green line, and just for simplicity, we've kept the safety level of those at the same level. In practice, they would actually look very different. It would actually be lower, but just to make the graph easy. And you could see what this does to your inventory. Now you're having to manage more complexity, but you could have reduced your inventory by as much as 40%. Most VPs of operations that I speak to think a 40% reduction in inventory is absolutely worth it. Moreover, you reduce your freight cost. Moreover, you increase your customer sat. When you add these, the economics are absolutely indisputable for the right kind of company, i.e. a company that has configured product. So other considerations is that this model brings back jobs to the United States. Key point I want to make here is these are economically justified jobs. These aren't charity jobs. So while this may appeal to a socially responsible exec, this will certainly appeal to an economically responsible exec and business manager who wants to save money, but actually doesn't mind having more control and certainly likes the bragging rights that comes along with the fact that, hey, we're creating jobs over here. Secondly, it requires an openness to becoming involved in your supply chain because this is hands-on, it is more involved. You probably will have to add a person or two. but the return on time, return on money invested is more than worth it. Because this not only reduces cost, it actually enables alternate marketing channels. It enables different supply channels, distribution channels that you might not otherwise be able to respond to. So what we're going to do is go over a simple case study. This is a configurable mass storage device. It's a retail device in this case with very volatile demand. Tough to forecast because all things consumer, color, capacity, all these things change from month to month. And even worse, the client, in this case, the OEM, effectively owns channel inventory via price protection agreements. So if you're not in the retail business, price protection basically means you have to keep ownership of the inventory. If the price goes down, the retailer is going to come right back to you as the OEM and say, I need a refund, please, because you reduced the price of this product. I haven't sold so much of it, so I need a refund. The effect is, for those of you that are not from the retail industry, is you own your inventory all the way out until it's sold to the consumer, and guess what? The consumer can still return it also. So you actually own some inventory in the field. They're changing requirements from retailers all the time as they kind of try to manage stock and change products and deal with competitive things. High freight costs for fully packaged product. This is very typical for retail products. Use of air freight to mean demand volatility. There's some of that. I've seen retailers that go all the way from 5% usage all the way to 40 or 50% usage, though they try to use air to handle fully packaged products. It's tough to do that. Sea freight to handle prepackaged product. And then there's price erosion because all consumer electronics are changing in price, and this one, mass storage device, is changing at the rate of 5% per month, resulting in obsolescence. So the customer here wanted to preserve the global supply chain, but had to increase flexibility. Very common in the retail industry, and actually fairly common in the non-retail, i.e. tech industry in general, and increasingly common in not tech industries also. Lighting would be a great example of this. So in this old model, the freight costs of the product were $2 a unit when they bring it in by air. When they bring it in unpackaged, unconfigured, the transportation cost dropped to 10 cents per unit. A huge difference, guys. Secondly, the order lead time now, before the product could come in from Asia, sometimes have to get configured in Asia, brought in minimum 2 weeks with unconfigured product sitting in the domestic fulfillment center, reduce the supply chain. I'm being generous here when I say 3 days, oftentimes 24 to 48 hours. Stock out percentage, because you have to forecast multiple SKUs, dropped from 40% stock out to less than 10% because sometimes components were misforecasted, though that number dropped drastically with time. The client inventory profile dropped from finished goods, heavy finished goods, to finished goods being almost eliminated, reduced 80%. And rework costs dropped from over $100,000 a month to basically being eliminated because the supply chain did not involve any rework. No finished goods were kept in stock unless they were very well known to be high runners going to large retailers like Walmart and Target. So these kinds of results are amazing. And so the next question people typically say is, well, okay, I want to move to this model. How do I do it? And I think much as people want to rush into it, our suggestion is go slow. Start in baby steps. Pick one geography, one product line, preferably only returns in some scenario, or only one product in one scenario, your most expensive product. Prove the model, understand it, get to know your subcontractors, get to know your local vendors. But start doing this right away because things are getting worse. Exchange rates with China are changing. Exchange rates, labor costs overseas are increasing. Products are becoming more expensive, not less. And your competitors are already beginning to do this. So realign risky steps and products into a last mile solution quickly, and then start designing flexibility and adaptability into your product. Do it such that you can source certain components domestically inexpensively. Print, classic example. Power supplies can be brought in ocean freight. Use local power supply vendors that source overseas, but let them take the inventory risk. Develop relationships with second-tier and third-tier contract manufacturers in Asia who you can control, as opposed to using large people. And with last-mile vendors here in the U.S. that are integrated, that have the right software, that understand the model. But start doing this now before your competition forces you to do this. So in summary, demand volatility is a significant problem for companies with global supply chain and global customers and consumers that are now beginning to change. Companies are rethinking supply chain architecture, realizing they need flexibility not only to manage costs like transportation and inventory, which were originally looked at as being cost of doing business, but they're rethinking supply chain architecture to manage inventory costs also. This new supply chain solution gives significant cost savings and flexibility. It's easy to implement in stages, and there's actually benefits to it. So with that, what we can do is we have about 10 minutes for questions and answers. I suspect this wasn't all that easy, and I have no problem with anybody reaching out to me offline to talk about implementing a last mile supply chain solution for your company. So with that, I'll just turn it over to Doug or Michael for any questions that may have come in during the webinar, and if there are any, happy to take them or take them individually. My contact information is should be on your screen right now, and feel free to contact me by email or phone. With that, I'll turn over the mic to Doug if there are any questions.
Yep. Thanks, Sandeep. We do have a few questions here. The first one from Randy, and the question is, how do you define the items that actually belong in the last mile part of the supply chain? How do you identify those items? And what would characterize those items that go into the last mile solution?
Okay. So I think, and please feel free to use the chat feature, Randy, if you've got any, if I didn't get the question right, but I think the question you're asking over here is, how do I identify the items that get added in at the last mile of the supply chain? Well, the way you typically do that is identifying their risk to your business and their cost to your business. Risk is the IP risk, sourcing risk, and the volatility risk associated with those products. So this risk side of it. The second side is the cost. If the landed cost of that product and the integrative cost and the integration cost of that component in your product is lower in the last mile than it would be in the globalized piece of your supply chain, then you understand it. Now, typically what this means is parts that add configurability to your product, memory, processors, packaging, power supplies, things that are heavy, power supplies, things that can be sourced at almost the same price domestically as in Asia. Printing, I think, would typically fall into that category, or things that can be brought in by ocean and stocked in a local location. Again, power supplies, cables, things like that would typically fall in that category. And things that add to the configurability of your product. Software is a classic. UPC labels would be a classic. Memory, processors, firmware. So there's a lot of items that will add and configure your product from A to B, or to use the example that we had earlier, to take it from finished good 1 to finished good 2 or finished good 3, but the change may be very subtle. And then understanding the cost aspect. And finally, then I'll add on this piece of the risk, the IP risk. If there's certain things you don't want to have at your subcontractor in China or in India or in Vietnam because you're concerned about control of your IP. That very often applies to software and other forms of IP. I hope that answers your question. If there's anything that came in on chat asking for clarification, no, there isn't anything, so that's fine.
Yeah, that sounds good. Next question is from Chris. Does it mean that you need to source last mile components locally here in the United States, or can you still source some of those components overseas?
I think the answer is both. You can source some in the U.S. or in Europe or in Asia, wherever your last mile is. The real decision is, what is the landed cost of that component? How much freight do you save? How much labor do you save? And how much labor do you add on in your last mile? When you do the math on those numbers, and it makes sense to do it in the last mile for that, for economic or risk or IP protection reasons, you can source that component wherever it makes sense. This model, the nice thing about it is it's completely economically agnostic. There is no agenda to it other than economics.
Okay, we have a couple more questions. Last two questions here. First one is from Walter. How does one estimate the savings in cost? Is there an easy way to start to get a feel for how much one would save?
The reality is that you have to work through cost in a number of, there's a lot of costs involved. There's a lot of costs, a lot of savings. You have to manage transportation cost. You have to include transportation cost. You have to include risk. You have to manage risk in this. And what is the risk of your supply chain if it's handled at one supplier? You have to look at the cost of money. You have to look at the cost of inventory. The cost of money, cost of inventory, cost of transportation, the increased cost of labor in the U.S., which is always a factor. All these things are very easy to quantify. What is harder to do sometimes is, what is your obsolescence going to be? If you stock too much inventory, how much of that inventory are you going to have to write off? How much are you going to have to sell to, Big Bob's retail outlet or the dollar store that just lets things go for nothing? And not only does it result in a write-off for you, but it also results in compromising the value of your brand. How much of this product do you have to throw away? How much of this product do you have to rework? So there's a lot of costs that have to be added up. At Extron, we've documented all these and have some models, but I'll tell you this, that the number of hidden costs are huge, but oftentimes this can be justified just based on obsolescence, inventory cost, transportation cost savings. These three typically justify it for most people, but there's a heck of a lot more.
Okay, very good. And then the last question is from Mike. The question is, are there certain types of products that tend to lend themselves well to a last mile solution? Can you give us some examples of ones maybe Extron has done?
Yeah, absolutely. Very typical is electronics. That's the most common one we see. Anything that's high-value electronics, because the reason is people want to fly those in typically, and they can be just simple freight savings. Forget anything else. Even if you're just flying in finished goods, just the freight savings alone can sometimes pay for it. But that's a very typical one. The other is products that are highly configurable. I hope I got the question right. So the typical would be electronics, configurable products. Now, what we're beginning to see lately is more and more products that have any kind of configurability. Sometimes they may be really cheap. But even if they're being transported by container, the inventory cost is now making it worthwhile. We actually just won a new customer that is not a technology product, that, believe it or not, is a metals product that's reasonably expensive. But they were doing their manufacturing in Korea, and what they have found is that it is now cheaper for them to ship in nested raw materials from the component vendors in China, ship the product here, and have the product assembled here in the U.S. The reason is they have thousands of SKUs. And so building thousands of SKUs and stocking inventory because their customers expect immediate fulfillment of the product is not practical. They need to configure the product right here. And I'm talking about a fairly inexpensive product, but the inventory costs became a determining factor, not even the transportation costs. So there's a situation where product now being made in Asia has actually been moved back to the U.S. because the product, the exchange rates and inventory costs completely skewed the deal in this. There's another customer, again, also higher-end metal-related products with a lot of customization, aluminum extrusion-based products that needed to move this domestically from Germany in this case. So electronics, but increasingly non-electronics product. That's why I think there's a lot of legs on this model.
Okay, that sounds good. There are no more questions at this point. I want to thank everybody for joining today's webinar. We're going to have a recording of the webinar available on the Extron website at www.extroninc.com, and I wish all of you a great day.
Thank you so much. Bye-bye.